This is one of the interactive figures that you can access through Mastering Astronomy. I think these are really nice because they're short little videos that talk about some of the concepts that you read about in the book, but they show it to you in a visual way, so it makes it a lot easier to understand. First, I just want to point out some facts that you might not be aware of that could help you orient yourself in the sky at night. Two northern type constellations that you always can see at night are the Big Dipper and the Little Dipper. And when I say northern, what I mean is if you look towards the northern horizon and then look upwards, you should see those constellations. The Big Dipper is usually easier to find because of the handle and then the 4 stars that make up the ladle of the Big Dipper. If you use these 2 stars right here at the end of the ladle, we call those pointer stars, as you can see in this picture. And if we follow them upwards into the sky, the first star that you come across is Polaris. Remember I mentioned Polaris is the star that lies directly above the North Pole of the Earth, and that makes it pretty important. Because of that, when the Earth is rotating at night, which causes the stars to appear to rotate, they actually are moving around Polaris. Polaris doesn't really move at all. That's why it's important. You might notice that it's not all that bright, and a lot of times people don't even notice it because they're expecting it to be very bright, because Polaris is always mentioned and it seems important. So the assumption is that it's really bright, but it's not. So Polaris is the very end of the handle of the Little Dipper, and then if you look really closely, you can find the rest of the stars. Sometimes around Providence, because there's a lot of light pollution, these 2 end stars are the easiest ones to find, and not until it gets really dark later at night can you see the rest of the Little Dipper. In any case, I just want to show this interactive figure that shows how the stars move around Polaris during the course of the night. So I'm going to hit the play button. And notice how they're moving. Notice Polaris isn't moving, but all the other stars are rotating around it. Let's do it again. Notice that they're moving counterclockwise. That's due to the Earth's rotation. So remember, this is sort of a case of relative motion. These stars appear to be moving in circles, but it's actually because on Earth we're rotating in a circle as the Earth is rotating on its axis. So over the course of the 24 hours, all these stars will make a complete circle around Polaris. How we see these circles depends on where we're located on Earth, how close we are to the North Pole, etc. One last thing that you might have learned about in your reading, but I want you to remember, is that the altitude of Polaris, and remember that's the angle it makes with the horizon, is equal to your latitude. So here in Providence at about 42 degrees latitude, Polaris is about 42 degrees above the horizon, the northern horizon, which means it's about halfway up from what would be directly overhead, because directly overhead would have an altitude angle of 90 degrees.